Download this code from codegive.com, link in the description below. Certainly. In machine learning, bias and variance are two fundamental sources of error that affect the performance of predictive models. Understanding the trade-off between bias and variance helps in selecting the appropriate model and tuning it for better performance. Bias. Definition: bias refers to the error introduced by approximating a real-world problem, which may be complex, by a simplified model. High bias can cause an algorithm to miss the relevant relations between features and target outputs, underfitting. Example: a linear model trying to fit a nonlinear relationship will have high bias. Variance. Definition: variance refers to the error introduced by the model's sensitivity to small fluctuations in the training data. High variance can cause an algorithm to model the noise in the training data rather than the intended outputs, overfitting. Example: a very complex model, like a deep neural network, trained on a small dataset may fit the training data perfectly but perform poorly on unseen data. Bias-variance trade-off. The goal of a good machine learning model is to find a balance between bias and variance to minimize the total error. This total error can be expressed as backslash text total error equals text bias 2 plus text variance plus text irreducible error. Code example. Let's illustrate bias and variance using Python and a simple dataset. We will use the sklearn library to create a synthetic dataset and train different models to observe the bias-variance trade-off. Step 1. Import libraries. Step 2. Create a synthetic dataset. Step 3. Define models. We will use 3 different models to observe the bias-variance trade-off: a linear regression model, high bias, a decision tree, high variance, and a random forest, which balances bias and variance. Step 4. Train models and evaluate performance. Step 5. Visualize results. Analysis of results. 1. Linear regression. This model will likely show high bias, underfitting, because it cannot capture the complexity of the data. 2. Decision tree. This model may show low training error but high testing error, indicating high variance, overfitting, because it captures noise in the training data. 3. Random forest. This model often balances bias and variance, providing a good prediction on both training and testing data sets. Conclusion. The bias-variance trade-off is a critical concept in machine learning that helps in model selection and evaluation. By analyzing the errors of different models, you can gain insights into how they will perform on unseen data, guiding you on how to adjust your models for optimal performance.